simple objectives. One was that we will design and manufacture a vehicle body that will adhere to all regulations by Shell. Two is that we will create a steering and handling system that will optimize our performance. And three was that we would create a motor and energy system that used the least amount of energy, but gave us enough power to move our vehicle. We, as our team before us stated, we divided the competition and our design into several different sections. We have the vehicle body, the motor system, as well as the steering and handling, while the other team is working on the chassis as well as the wheels and brakes. These are a list of competition regulations as well as constraints that we must follow. For example, the vehicle cannot pass 100 centimeters in height or 350 centimeters in length. Also, because we chose battery electric, we must have a battery management system that has cell balancing and over voltage protection. Also, it must isolate the battery from the energy system if anything were to occur. In addition, we have an emergency shutdown mechanism that must activate outside or inside the vehicle for any emergency. As well, we also have the dead man switch mechanism that just in case the operator faints or passes out while the vehicle is in operation, the vehicle will automatically shut down on its own. Another design standard that we use was for the aluminum 6061, since we were considering to use that material for the body as well as the chassis. We used the tensile limits from the American Society for Testing Materials, which are listed right here. And also, we used the International Organization for Standardization, their standards for battery electric vehicles in general. For example, the post-crash electrical safety and anything for energy storage systems. Now, Evelyn Mojica is going to talk to you about our body design and different alternatives.
Alrighty, so my name is Evelyn Mojica. I will continue discussing our body design alternatives. So using the geometric constraints that we have for the competition, we came up with our first design alternative. And moving forward, the second design, this alternative was optimized to come up with our second body design. The third from there on out is this one, and then all three, I'm moving fairly quickly through these because I'm going to talk more in depth once I get into the airflow analysis and what we looked into in selecting our body design. So what did we look into? So we wanted a vehicle body that had a good aerodynamic shape, reduced drag. We want to be able to reduce that drag. We need to prevent turbulent flow around the shape of the vehicle. So as seen in this picture on the right, the two middle figures, for example, the third one has too steep of an angle at the rear of the vehicle body, and it causes increased turbulent flow around the body shape, which increases our drag and lowers our vehicle speed. So these are the factors that we looked into and moved on to our airflow analysis. So with the first body design alternative, it did have a uniform velocity throughout the body of the vehicle. However, towards the rear of the vehicle, due to the steep angle in the end, we did encounter some turbulent flow. As you can see, it did bring our velocity towards the lower end of the scale and increased our drag. For the second design alternative, it did look a lot better than the first one. However, as you will see in the next slide for our third vehicle design, the overall speed around the body is on the lower end of the scale. And here, it's more uniform towards the higher end of the scale, which means it has reduced drag, reduced turbulent flow. The turbulent flow does increase towards the rear of the vehicle. However, we've decided that by making the body of the vehicle slightly longer, we can work towards reducing that turbulent flow that we encounter there. This is the technical drawing of the body that we decided to choose. And so as I mentioned, by increasing the rear of the body of the vehicle, we can reduce that turbulent flow. Right now we're at about 338 centimeters, and our constraints for the competition are 350 centimeters, so we still have some room for improvement. And now Santiago and Norena will discuss our electric motor options.
All right, so in selecting our electric motor, we had to look at different options for energy source, such as hydrogen fuel or internal combustion. However, we decided that the most feasible option was electric motor due to logistics and constraints of cost. Also, there are team members with previous knowledge in programming, which would make it more viable of a reason to do the management, the battery management system for the vehicle. Now, before selecting the motor, we did some research on the different types of motors, such as direct drive motors or gear motors. The direct drive motors, they are faster and they are heavier. However, on the other hand, the gear motors have less drag, are lighter, have more torque, and on the downside, they do have lower top speeds and they have higher noise. I use this by comparing, let's say, motors of scooters and electric bicycles. Now, this is the first option that we selected for the motor alternative. This one at top velocity uses 36 volts, 500 watts, and has a maximum velocity of about 50 miles per hour and has a greater efficiency of 80%. As you can see, in this option, the motor is connected to the wheel, which will be placed at the rear end of the vehicle. And this option is also a kit, which will lower the cost, our total cost of manufacturing and assembling of the vehicle. Our second alternative that we selected was a similar option. However, top speeds, this uses 48 volts and twice as much watts, 1,000 watts. And in this one, in this option, it goes up to 28 miles per hour. It also keeps an efficiency of greater than 80%. And this is also a geared system motor. Now, the third option we decided to look at was a direct drive motor by analyzing motors of scooters. In this option, as you can see, it has a 24-volt battery at top speeds of 450 watts and has efficiency, however, of less than 70%. And on the plus side, this goes up to speeds of greater than 35 miles per hour. Now, the next step in selecting the motor of the vehicle, we decided to make an assessment of the different alternatives by making a relation between power, current, and voltage of the three different alternatives. Alternative one, as you can see, draws the least amount of current. However, there are other factors that need to take into account, such as the weight of the battery, also the weight of the motor, as well as if the power is sufficient enough to move the weight of the vehicle. Over the next few weeks, we will be looking at different factors, as I just mentioned, to make the finalized option of the motor.
Alrighty, so this is our current timeline where we're currently moving forward into finalizing our cost analysis for all of the components in conjunction with the previous team and finishing analyzing the material that we are going to be using for both the body and the chassis and moving forward into purchasing and finally manufacturing and assembling everything. So what we've completed so far, we've done the CAD models as you saw in the presentation of all of the design alternatives, the technical drawing of the preliminary design, and we've registered for phase 1. We're waiting to hear back by December 8th whether or not we've been selected to move forward to phase 2 of the competition. And we're continuing with research and development and, like I said, the selection of materials and the costs. Questions?
That front panel you have there, different color, is that glass, plastic, same material as the rest of the body?
It's plastic.
Plastic.
It's hardy carbon.
Yeah.
Okay.
The regulations recommend using that just for the stability as well as the ease of forming.
Do you have any vents for the person inside?
Oh yes, there needs to be a vent in the rear for the motor, where the motor's going to be, and then in the front for the driver. And also the plastic window needs to be detachable so that the driver can exit the vehicle, I think it's within 5 seconds, if I'm not mistaken.
Okay.
Okay, I have several questions. My first question is, what effects will any change in design of the previous team have on your design and the work that you already done? As you noticed in the previous discussion, you're talking about maybe changing design as far as the height, etc. What effect is that going to have on your design And as far as timeline, etc., is what you have to do. It's going to really mess up what you already have, or you have to start back from square one, or it's not going to really affect it.
Well, as the alternative 3 that we have so far, this was made using the maximum constraints that the competition allows us to have the body as. However, you also use the constraints of the other team's design of the frame. If they wanted to make it bigger in height, as they mentioned, that would be very, it wouldn't be viable. But if they wanted to make it greater in width, that could happen. So we are working in an iterative process. If they decide to make changes, it would affect us. That's why their option in their frame so far follows through with what we have so far.
So does their chassis match that design?
Yeah,
Yes.
everything here was made based on their chassis design.
Yeah, our maximum height for the vehicle, according to the competition standards, is 100 centimeters, and right now we're at 98 centimeters. So if they were to make that chassis higher, it would affect the body, and we need to stay within those
So
constraints to be
the
able to.
tail end of your body is substantially farther out than the end of their chassis?
Correct.
So if they attempt to make the changes with the height, as they were talking about, that's going to mess you up.
Yes.
And
It would to a point because we do have to go within the 100 centimeters. However, there may be a chance that we can have the driver leaning back more, although the safety for that will not be as great as them being to sit straight, and the comfort for it as well, because as the reserve driver, I don't think I could lean back and drive just as perfect.
And also, we're trying to keep it so that the majority of the weight of the driver is towards the center of gravity of the vehicle to keep the weight distribution balanced. So in terms of height, there would be some issues there if they want to try to make it higher. They can play with the length as much as they want, but.
But
We
you-
made an analysis of the interior sizes of the body for them to keep thickness of the thickness of the body of about 5 millimeters, was it, if I'm correct, for the body, and using those constraints of sizes. If they were to make changes, as long as they keep those constraints, they're able to make.
But you guys are working together, so
Yes.
you'll be communicating,
Oh,
and you communicate that fact to them but you can't do that because it's not going to help you guys.
no,
Yeah, everything
Okay.
we've done has been working together. That's how we also were able to come up with the body. We did it after they came up with the chassis to ensure that whatever we came up with went in sync with what they came up with, and so on and so forth. Otherwise, I don't think we'd be able to put this vehicle together.
Now, my other question has to do, you mentioned the fact that you're final from December 8th, which is not too far from now, whether or not you move on to phase 2 of the competition. What happens if you don't move on to phase 2?
So if we don't get selected for phase 2, we will still be moving forward and making the vehicle in hopes that next year's team can work off of this and go to competition. I don't see why we wouldn't be chosen. We submitted everything that they requested as far as technical drawings and our 3D model. They didn't even request a 3D model, but I gave it to them anyways. The CAD model of our vehicle. So if we don't get selected, we don't go to competition, but we can still build the vehicle.
But there's no limitation as how many cars can move on to phase 2. Is there a limitation? Or is there-
They don't mention limitation, but they're saying that this year they can only have, I think it was 125 competitors.
So there's a limitation, but it's 125.
Yeah.
Okay, so that's not too bad.
Exactly.
Um,
Worst comes to worst, we won't go to Michigan.
Now, one of the main goals, I think, of this competition is reaching the highest possible fuel efficiency.
It's reaching the longest distance using the least amount of energy.
Right. And what specifically are you guys doing to try to maintain or to achieve that goal?
A lot of what we're doing is taking into account the vehicle weight and also the capabilities of the motor, so that we're playing between efficiency and power of a motor and the weight of it, so to be able to achieve our goal on that. And then with the testing, we'll be able to determine whether we chose the right one.
What is your body made out of?
The 6061 aluminum.
Why did you select aluminum over, let's say, a Mylar skin?
Well, right now, we haven't made that as a final decision.
Does it have to be structurally sound, I mean, the body? Or could it be basically a wind resistant surface over a structural substructure?
I would like for it to be structurally sound, but
Can you afford the weight?
The problem is that the chassis already, as you saw, was 76 kilograms, and the full weight of our body cannot surpass, what was it, 140 kilograms? So if we use a heavier material for the outside.
Lighter.
No, he's suggesting later.
Lighter.
Oh, lighter,
Yeah,
yeah.
he's suggesting later. Well, we can look into that
Mhm.
and see overall how that would affect the body design, but that would be a good idea.
Is in Mylar, wouldn't you lose your aerodynamic shape though?
Well, I mean, you would put in like an airplane structure for Mylar.
Right, so you would have to
A
add,
balsa frame or something like that that gets you your shape, but
Well, other than the weight of the vehicle, the other constraint that they give us is that the shape of the vehicle cannot be affected by wind speeds. That's it. So we can essentially choose whatever material we like.
besides the body, you're doing also the motor, the brakes, the
No.
wheels?
Motor, steering, and handling. The brakes and the wheels is being done by the previous team.
Okay.
yeah, so talk to us a little bit about the steering.
That's coming up in the next phases of this project, where we will be continuing with our research and development. I think it was on my last slide. So the research and development portion of that is moving forward with the steering and handling. We focused a lot of our efforts this semester on coming up with the body, making sure everything is good to go in conjunction with the chassis, and that has kept us very busy.
So I know the wheels are not part of your team, but since it affects the same project, have you done any, or have you put any thought into the size of the wheels? What's better for you, bigger wheels up front or smaller wheels up front and a bigger wheel in the back?
Yes, we decided, I believe it was a 26 inch in
Yeah,
the
so
rear.
far it's 26 inch in the rear. And we were thinking of either try to keep a similar 26 inch in the front to keep us, a balanced, stable body. However, if we were to pick 29 inch in the front and bigger, we have looked at those options. However, we haven't done the validation for selecting the size of the wheels.
When you pick that, think about your aerodynamics as well. Redo your analysis
Yeah.
because that your wheelbase is going to affect that.
Yeah, and another thing we're looking at when he was speaking about the motor is the geared system versus the direct drive, at least for the rear wheel. That's the sizing of that, depending on what's available or how that works, is going to affect that decision as well.
As well as when we create the software or the controller, when we make the program that will manage the power that's sent from the battery to the motor, we want to be able to create a code in which it will cut off the power when it reaches maximum velocity, and it will just ride on its own momentum. And at that point, we'll be able to save all the energy from the battery. And it will coast between, I would say, if we get to like hopefully optimal speed, if we're looking for is 20 miles per hour, it will coast between 20 and 10 miles per hour at that point.
That's it.
Thank you.